Hello everyone. In this video, we'll see the simple RL circuit response for a step current input. So current is 0 ampere, okay, till t is equal to 0 seconds, and at t is equal to 0 seconds, current suddenly rise from 0 ampere to I ampere, and it is staying there. And we need to find what is the VL voltage and VR voltage during the uh, whole process. So till t is equal to 0 seconds, the current is 0 ampere. So during the 0 amperes, I can replace the current source with the open circuit, and VL is equal to 0 volt because the circuit is open and the inductor is uncharged and energized, and VR will equal to 0 volt because there is a open circuit here. There will not be any current flowing through the circuit. So we know that we then let's analyze what will happen to the circuit. So we know that during the t tends to infinity, so this is a DC current. Okay, this is a DC current. So frequency is equal to 0 hertz. So inductor acts as a short circuit. So I can replace inductor at t tends to infinity as a short circuit. So VL will be 0 volt and VR will be, so here the current I is flowing. So always this is a step current, so I is always flowing through the circuit. So there will be VR is equal to current flowing through the resistor and resistance of resistance. This is the I into R. So VR will be I into R volts. So then we need to see what will happen at t is equal to 0 seconds. So first we need to understand there is a what is the property of the current source. The property of the current source is it will maintain the fixed current, that means programmed current. Here the programmed current is at t is equal to 0 second, it must go from 0 amperes to I ampere, but it can increase the voltage across the current source till plus infinity to minus infinity. So the voltage across the current source can swing from minus infinity volts to plus infinity volts. So this is the property because current source must flow through current. So because there is no other way, so that should go through this inductor only. But we know that property of the inductor, what we know here, this is a high frequency components. Okay, because this is going from 0 ampere to high, so this is a high frequency component. Here frequency is infinity. For frequency tends to infinity, inductor acts as a open circuit. So we have a contradictory here. Why? Because at a t is equal to 0 seconds, inductor is not allowing the current to flow through inductor, and there is no other way parallel path, so it must go through the inductor. But inductor is not allowing the current to flow. But what current source behavior is, current source should source I current. So there is a contradict here. So something should compromise here, either the current source or the inductor. So but because the current source cannot compromise, because we are taking as an ideal current source, because the voltage across the current source can swing from minus infinity volts to plus infinity volts. So let's see at what condition inductor will compromise. So we know that VL is equal to voltage across inductor is equal to L di by dt, and I is equal to so let's see. So it L is equal to dA by dt. So I want to flow step current through the inductor. So if I replace step current, L is equal to d by dt of I into u of t. So if I am flowing, if I want to flow step current through inductor, there should be L into I into d by dt of u of t is equal to del of t. That means if I apply a impulse voltage across the inductor, then inductor allows the step current. So that is the only way which current source can continuously pump current I at t is equal to 0 seconds. So let's see whether this delta of t current t volts can be supported by the can be applied by the current source. We know that current source can provide, that means can swing the voltage across its terminal. That means voltage across this current source terminals can swing from minus infinity volts to plus infinity volts. so that this impulse voltage can be provided by the current source. That's how the inductor will be compromised and the step current will be flowing through the inductor. So there will be a voltage across inductor will be a step voltage at t is equal to 0 seconds, and the voltage will be 0. Then the inductor across voltage will be 0, and the step voltage, that means, sorry, it's not a step voltage, there will be impulse voltage applied across the inductor at t is equal to 0, and then the I current will be flowing through the inductor. In the same way, the voltage across the resistor will be this one only. So there will be a step current flowing at t is equal to 0 seconds also. That's why the voltage across the resistor will be only I into R. So from t is equal to 0 seconds to infinity, the voltage across the resistor will be I into R only. But the inductor is generally will allow I current at t is equal to 0 seconds also, because current source is providing is able to provide a impulse voltage. So I have simulated the same. Let's see. So I have taken 1 ampere and 100 ohm resistor and 10 millivolts, 10 millihenry inductor. You can see there is a impulse voltage provided by this ideal current source. It went to some 3k, around 3k volts. Because of that one, you can see there is a step current will be flowing through this circuit, and after this impulse voltage, VL became 0 volt again. This is 0 volt. So at after step voltage, VL became 0 volt.